Alright, so this is going to be the section that we deal with multiplying radicals. So far, yesterday's lesson is adding, subtracting them. We've done some simplifying of them. Now we move on to multiplying them, and this is actually going to be the easiest thing we do, okay, with radicals. It says multiplying radicals, easy operation. And conducting radicals. So when multiplying radicals, you will multiply the coefficients. Okay, so I'm just giving you an example down here. Like if I look at this one here, that -3 is the coefficient for radical 15. That -4 is the coefficient for radical 6. If we think about, if I had like 3x, that coefficient right there is telling me how many x's I have. This is telling me how many radical 15s I have. This is telling me how many radical 6's I have. So we can still refer to that number out front as a coefficient. So when multiplying radicals, you will multiply the coefficients that rest outside the symbol by one another, and their product will then remain on the outside of the radical in the answer. So when we're doing these problems, there's going to be two numbers. There's going to be a number left on the outside, and there's going to be a radicand. So there's going to be a coefficient for our answer and a radicand for our answer. Okay, that coefficient for your answer comes from multiplying the coefficients that are in the problem. Okay, the number that becomes the radicand in here is going to become, or is going to be generated by multiplying the radicands that exist in the original problem. Okay, so here it says you will then multiply the radicands together, and their product will reside on the inside of the radical when you write your answer. And that's how you multiply radicals. Okay, it's as easy as it gets. The only thing that becomes problematic when multiplying radicals is when we're done, because we're multiplying radicands, okay, we're going to get a larger radicand. And when we get a larger radicand than either of the things that we started with, generally that larger radicand can be simplified. So here it says you will always want to check that the final answer has a fully simplified radicand. As we do these, I'm going to suggest that you do not simplify initially. You don't simplify, because this radical 12 could be simplified. But what you're going to find out is if you simplify that, a lot of the times, the next step when you multiply, you essentially unsimplify something, and you'll have to simplify the radical again. So, in saving ourselves a little bit of time and effort, simplify at the end. Okay, always wait to the end to simplify when multiplying radicals. These radicands are 3 and 12. Okay, so there are coefficients out here, but they're understood coefficients. Understood coefficient of 1 there, and an understood coefficient of 1 there. So in my answer, okay, I want to have a number out front, and that number out front is that 1 times that 1. So I'll multiply those together. Okay, and then the number on the inside, the radicand in my answer, is going to be that 3 times that 12. It gives me 36. My hope is here that we can see that radical 36 is a perfect square. Square root of 36 is 6. Do the same thing over here, and this is we'll do this one twice, and I'll show you the kind of the logic of not simplifying radicals right off the bat. So I've got a number out front of 1 and 1. So I'll multiply those together, and I get 1 for my answer. And 8 times 2 is 16. I get the square root of 16, simplifies to 4. Now, if you remember, we've done radical 8 before. Radical 8 is 2 and 4, and then 2 and 2. It was a pair of 2's. So I could have written this radical 8 as 2 radical 2 times then 1 radical 2. Okay, so that radical 8 could change into this. So now if I got something like this, I take the numbers outside, the 2 and that 1, multiply them together. And I'll take this 2 times that 2 is the numbers on the inside, multiply them together. And this is the reason why I would not have simplified at first. Okay, we spent time simplifying that radical 8 just to turn around and eventually still have to simplify this thing here. So then radical 4 is 2, so I get 2 times 2, and that would still be 4. And that's not terrible to simplify that, okay, or have to simplify that, but I waste a lot of time doing this, okay, where if I look at doing it this way, the only thing I had to simplify is radical 16, and that wasn't very time consuming. Do this next one, so we'll go negative 4, so there's an understood 1 here, so negative 4 times by 1 gives me a negative 4 out front of my radical. Then multiply the radicans, 2 and 12, so give me 24. So I'll take radical 24, because that's not simplified. So I'll take that and goes 2 and 12, 2 and 6, 2 and 3. So there's a pair of 2's that can come out, so I have a negative 4 already out there. A pair of 2's can come out, and then these two things do not have a partner, so they get multiplied back together as 2 times 3, which gives me 6. So you get negative 8 radical 6 as this product. Okay, 2 times 1, gives me a number on the outside. 3 times 12 gives me 36 again. Well, 36 we know to be 6. So now I have 2 times 6, which is 12. So there the radical completely disappears. These next ones get a little bit more interesting. So we've got a number out front on both these. So negative 3 times negative 4 gives me a positive 12. And then 15 times 6 gives me 90. So then the 90 needs simplified. So 90 goes to 9 and 10. 9 goes to 3 and 3. 10 goes to 2 and 5. So 3 and 3 can come out. So I have 12 up front already. Group of 3's comes out. And then the 2 and the 5 stay underneath as 10. So we have 36. When I multiply those together, times radical 10. That's the simplified version of that product. Go over here. 5 times 5 gives me 25. And 15 times 20. The way I would do that, I'd go 15 times 2 is 30. So then times 20 would be another factor of 10. So now I need that 300. That 300 is not simplified, so 300 goes to 3 and 100. I'm going to stop there. I know we've been going all the way down to prime numbers there, but this is a perfect square. So what I can do is say that I'm going to have 25. If I take the square root of 100, that gives me 10. And then the square root of 3. So we get 250 radical 3. If you don't like it that way, obviously you can do the 300 goes down to 3 and 100. 100 goes to 10 and 10. 2 and 5. 2 and 5. And then you've got 2 2's. So that can come out. You got a 5 and a 5. That can come out. And then this 3 doesn't have a partner, so it stays underneath. So we get 10 radical 3. And there's the 10 radical 3 that we realized. These next handful, still multiplying. It's just other areas of multiplication that we've seen in the past. Like you guys can do this. You know how to do 3x, 3 times quantity x plus 2. You can distribute. That's all this is saying right here. You're going to distribute. So all of these have a 1 out in front of them. So we'll go 1. So we'll distribute this radical 6 to this radical 3. So we'll go 1 out front times a 1. So 1 times 1 is 1. And have radical 6 times radical 3. So it gives me radical 18. I'm then going to distribute to that thing. So we get 1 times 1 again. And then 6 times 10 is 60. So now it gets to what we were doing yesterday. We've got two radicals that we're going to add together. This 18 is going to go down to 2 and 9, 3 and 3. So this gives me, there's a group of 3's, so it gives me 3 radical 2. That's what radical 18 is the same as. 60 breaks down to 2 and 30, 2 and 15, 3 and 5. So there's a group of 2's that can come out. And then the 3 and the 5 do not. It gives me that. Now, remember from yesterday, if I want to add these together, that number there and that number there need to be the same. And they're not here, so we can't add them together. Let's leave it this way. This one's the same idea. We just now have coefficients that are not 1s. So I'm going to take this and multiply there. So we get 3 times negative 3. Number on the outside times number on the outside gives me negative 12. And then I have 3 times 10. So radical 30. Then we do the same thing. 3 times 5 over here, so 15. And then radical 3 times radical 3 gives me 9. So I'm going to simplify the 30. So 30 goes down to 5 and 6. 6 goes down to 2 and 3. And there are no groups. There are no pairs of 5s or 2s or 3s. So that's already fully simplified. We do know that 9, though, square root of 9 is 3. So I have negative 12 radical 30 plus 15 times 3. 15 times 3. So then I get negative 12 radical 30. 15 times 3 is 45. Now I can't, like radical, so 45, positive 45, that is the same thing as saying 45 radical 1, because radical 1 is the same thing as 1. So if I take 45 times 1, it's still 45, so 45 times radical 1 is still 45 times 1, so it's just still 45. Okay, so any number I ever had, like 12, I put radical 1 on it. It's much like saying 12 times 1, still 12. Okay? And the reason I'm writing it this way, just to prove a point, I can't add anything here, because that 30 is not the same as that 1. The radicands are different, so you can't do anything. Much like this problem over here, the yellow things were not the same, so we couldn't do any combining of like terms. Let's skip this one. Let's come down to this last one. This last one here is still multiplication. This one is a little bit nastier. It's foiling. You've got a binomial times a binomial. First times first. So 5 times negative 2 is negative 10. Radical 5 times radical 5 is radical 25. Now I'll do outside times outside. So 5 times 2 is positive 10. 5 times that 2 is radical 10. Now I'll do inside times inside, so these two. So 4 times negative 2 is negative 8. And then radical 2 times radical 5 is radical 10. And then we'll do last times last. So 4 times 2 is 8. And then radical 2 times radical 2 is 4. So now we can simplify. So that's going to give me negative 10. So radical 25 is the same thing as 5. Plus, now these two things are like terms because they both have the radical 10. So I can go 10 minus 8 and gives me 2 radical 10s. And this is going to simplify to a 2. So we got plus 8 times 2. So we got negative 10 times 5 is negative 50. Plus 2 radical 10s plus 16. So it's going to give me negative 34. When I combine that and that, plus 2 radical 10. Again, that negative 34 cannot be combined with this 2 radical 10. Because that negative 34 really has a radical 1 with it that we don't write. And that radical 1 is not the same thing as radical 10. So multiplying radicals, multiply a number on the outside, stays on the outside. Multiply the numbers on the inside, they stay on the inside.